Hi, in this video we shall be learning about DAX. DAX, which is nothing but data analysis expressions. So let's get started. In order to say if you know DAX, you need to know at least these kind of functions. The functions are sum, average, min, max, count, COUNTROWS, calculate, filter. These are the basic DAX functions which almost everybody knows, at least because we have been using these kind of functions in Excel, and we will just be using the same functions in Power BI as well. So if you learn these things, then you can confidently say that you know DAX. Of course, there are more than 200 DAX functions. So knowing each one of them is not important. It's not feasible and it's not required as well. If you know at least 40 to 50 DAX functions, that should be more than enough. Okay. Apart from that, we should also learn about contexts, which is row context and filter context. We shall be learning about all these things. And then, of course, we'll be learning about the basic formatting options, best practices in Power BI, what are X versus non-X functions in the next couple of videos. Now let's try to build our first DAX expression. Are you guys excited about it? I'm pretty much excited. Let's start with it. So DAX, what is DAX? DAX basically is data analysis expression. There are two different business logics which we need to work on. One of them is measures and one of them is calculated columns. Now, as per Google, measures and calculated columns both uses DAX expressions. The difference is the context of evaluation. A measure is evaluated in the context of the cell evaluated in a report or in a DAX query, whereas a calculated column is computed at the row level within the table it belongs to. Now, the theoretical definition might be very difficult to understand. Let me understand you in layman's term. Let me explain you in layman's term. So, first of all is measures. For example, you are dealing with a data set. Let's say you are doing some sales analysis. Now, if somebody asks you, can you tell me the total count of the records? Now, in Excel, what we do is select count star from table name. Simple. That gives us the total count of the records. Now, if somebody asks you, can you tell me the total salary of all the employees? What we do? Simply, we do select sum of salary from table name. Now, these kind of figures which are calculated across the table, and the value is, of course, a single value, right? Let's say somebody asks you, what is the total salary for people who are females? That means select sum of salary from table name where gender equals to female. Simple. Even if you are using a where clause, a filter or something like that, but based on the filter, at least you are calculating over the table, right? So that's basically a measure. And calculated columns are some sort of calculated columns. There are additional columns. Let's say you have two columns, which is first name and last name, and you want to combine them to create a new column, which is full name, right? So that's where your calculated column will come into picture. So anything you need, if you think that I want to create a new column out of it, use a calculated column. If you want to do some calculations from the tabular level, then you have to create a measure. Okay, once we get into the practical parts, more and more understanding will be there. Most of our doubts will also be cleared out. So let's start and create our first DAX function. Now we'll talk about calculated columns. They represent a single value per data model. They are computed at runtime. Results are dynamic based on filters. This is called the filter context, not attached to any table. So we'll quickly skip to this part, but yeah, of course, I will be showing you what is the basic difference between calculated columns and measures. So let's try to create some calculated columns. Now, we are already using a churn modeling data set. You can see, if you want to see the data, this is how the data looks like. Simply customer ID, age, bills. Let me just have everything as much as I have. Okay, so everything is there. I'll just push my row number to the top one, just like this, and surname again to the top. So this is how my data looks like. Okay, this is how my data looks like. I have row number, I have customer ID, I have everything. Now this is how the data looks like. Now if somebody asks me, can you tell me the total salary of all the candidates, that means I want to do a summation of all the entries, right? So what we do in Excel is we just select the entire column and do a sum operation equals to sum of something, simple, right? Similarly here also what we need to do is we need to create a new measure, and that measure is total salary. Here I'm going to call my sum. So when the exact same piece of thing which we do in Excel, we are doing it in Power BI. Now the beauty of Power BI is that whenever you are confused about any DAX functions, you just have to type in and then it will show you everything. Like it will show you what it is expecting, what is the exact meaning of this function. You can see I have just typed sum, and I also see sum is nothing but adds all the numbers in a column, right? So I will be calling sum on a column name. Now what is that column? I will be using estimated salary. So I will be calling on estimated salary. That's how it is. Of course, if you ask me what should be the total salary for a particular gender, let's say male or female, so that's where your filter operations will come into picture, your where clauses, right? In SQL, we do select sum of salary from table name where gender equals to male. So that where clause is basically a filter, right? We will be learning about filter in couple of next sessions. But at the moment, let's try to understand the basic difference between calculated column and a measure. Now we already have created the total salary. Now calculated measures, you can easily use them as cards. You can see I'm initiating a card. Let's say I'll just keep it here. And here I'll just simply drag and drop my total salary, and that's how it looks like. My total salary is 1 billion. If you don't like the units, if you want it in millions or in thousands, just click on this visualization, go to the formatting options, data label, display units to thousands, and this is how it is. Just expand it. This is your total salary, right? And if you want to give a border and a shadow, that's it, done. So this is how your total salary looks like. Now, this is a measure that is calculated across the table. Let's say you want to create a calculated column. Now, if you remember, okay, so let's try to create the easiest calculated column. Let's say we have tenure, right? Now, business wise, everybody knows what is a tenure. Tenure means how long the customer is in the system with the company. Let's say I'm using one network, let's say Vodafone. I'm using it from the past 5 years. That means I'm a customer of Vodafone from the past 5 years. So my tenure is going to be 60. That means 5 years or 60 months. So here I assume that the data is in months because it's 49, 48. It could not be years, right? I mean, this is just my assumption. Let's say it's in months. I want to create a new column which is in years, or else vice versa. So I will be creating a new column. Here I will have tenure in years, which is I'm going to call tenure divided by 12. Okay. And then I have it. And then in the table, I'm just going to click this, simple. And you can see this is how my tenure in years looks like. Of course, if you want to round it and all those things, everything is possible. Let's say you want to round it. So there is a function called as round function. As soon as you hit enter, it will show you what it is expecting. It expects a number and it is asking you number of digits. That means rounds a number to a specified number of digits. Let's say your number is basically this one, right? And after that I want digits. Let's say I'll have 1 digit, and then close the bracket and tick. It will be dynamically updated right now. Now let's say you don't want to have any digits, then it will be rounded off to zero decimal places, and that's how things work. So let's say you want to have it in 2 decimal digits, and that's how it is. So every function you use in Power BI is going to be very simple. The moment you type in, it will also show you what is it expecting. So it makes our life easier. And of course, you can also check out the Power BI, Microsoft Power BI's official pages. They also have a clear explanation of all the DAX functions. So this is all about the basic calculated columns and measures, right? This is how you can see the calculated columns are created. And of course, we have also shown you how the measures are created. The filter functions and all those things, we'll have that covered in the couple of videos. Now the next topic is going to be implicit measures. If we use a calculated column as a value or result, it creates an implicit measure. Okay, so that means you are creating a measure where you are using a calculated column. Let's say I want to create a measure which is total tenure in years. I want to have the total tenure in years, so I'm doing a sum operation on tenure in years. Sum operation of tenure in years, simple, and click OK. I will create a card. Here I will just display my new created column. So this is my total tenure in years. Okay, of course, this is a measure. We have also created a measure for this, right? We have just created a measure. But what it says is, if you are using a calculated column in a measure as a value, it creates an implicit measure. So this is of course a measure, but it's a special type of measure. It is called as an implicit measure, which is used based on a calculated column, right? Because our calculated column is tenure in years, right? Tenure in years is our calculated column, which is based on tenure, and we have done a round function. That's a calculated column. And here I'm using the same column to create a measure. So that's the reason it is called as a implicit measure, simply. If we have columns such as tenure in years or monthly average usage, and let's say we want to create the overall average usage for that particular customer. Let's say churn of tenure months equals to churn of tenure into 12. So let's say in case your tenure is in months or is it in years, you're just converting into months or years, vice versa. So that's where your first calculated column looks like, right? We have already created that. And let's say you are doing some column or creating some measure out of a calculated column. That is why it is called as an implicit measure. Now, what it basically means is that, let's say if I change my original column, that means this column is created with respect to this column. I mean, this column is using tenure in years is using tenure, and total tenure in years is using tenure in years, right? That means if you change in the original column, that is your tenure, of course these numbers will change. If you want to see that, of course we can see. Just remember the numbers. This is 4.18k. Okay, 4.18k. So here what we will do is we will just change the tenure. Let's say I will do replace values. Let's say I'll select the column replace values. Randomly I'm changing 1 to 10. Okay, just like that, just to check whether the change in tenure is changing the calculated columns and the measures. If I click on OK, close and apply, so it was 4.18k. Now the numbers should change because we have changed the original column. So it's loading. Yeah, and the numbers are changed. And this is how you can identify an implicit measure, or you can create an implicit measure. So that is all about implicit measures. Of course, we have a lot of videos related to DAX functions and all those things. Now, moving on to the next one, which is DAX is good at two things. Now, if somebody asks you why DAX, so you can just simply answer these two things. One is aggregations. The second one is filtering. Aggregations, of course, how to aggregate. if we already know statistics and all those things, we know that we can aggregate using sum, average, minimum, maximum, distinct count. These are all your aggregators. Aggregations is a combination of group of values into one value. Let's say you want to group by based on gender. So you want the total numbers for males and females. That means you're aggregating the values, right? So DAX is good at two things. One is your aggregations and one is going to be your filtering. So let's do a sum operation. We have already done a sum operation. Now, my next question is, so this is my total salary, right? And if you want to validate this, you can see here also you can validate the total salary is matching this number. One more thing, what you can do is, if you are using this data from an Excel sheet, open your Excel sheet, do a equals to sum operation on your estimated salary. It will give you the results and you can verify your data. And if in case you are using a live data connection, let's say from SQL data, so of course you have to use some select query, select sum of estimated salary from table name, and whatever number you get, just validate with the number you are getting in Power BI. That's how you can validate your numbers. You can validate whether you are actually doing it correct or not. Okay, now let's try to understand the DAX breakdown. Now if I'll just open this same thing, let's say we'll open the total salary. So you can see total sales equals to sum of something. That means total salary equals to sum of something. Now this equals to is basically an assignment operator, right? We are assigning some values to a particular variable. Total sales, here the total salary is a variable. This is the name of the measure or your calculated column. You will be using that in the visualization. So anywhere you want to use, you can use this particular name. Equals to sum. Sum is basically your built-in DAX formula. There are many other formulas, average, min, max, blah, blah, blah. And then in the brackets, I am passing my table details, like which column. So you cannot directly use estimated salary. If I just call estimated salary, I mean, how will Power BI know what is this? So you can see I'm getting an error, right? Because Power BI does not know what is estimated salary. Is it a column? Is it referring to some table? We don't know, right? So we have to always mention table name in the brackets, column name. It's very simple to Python pandas, right? Whenever we are dealing the data with pandas library, we know that we are importing pandas as PD, and then we do create a data frame which is pd.read csv or your Excel up to your data, and you provide your file path, and that's how you read your data into data frames. And then let's say you are creating some total salary in Python. So what we do is total salary equals to df. We use our columns like this, right? df of estimated salary, right? Let's say into 100. Let's say I'm just creating a new variable which is estimated salary into 100, right? So I use it like this, right? Table in the brackets, my column name. That's how you use it in Power BI as well. Table name in the brackets, column name. Okay, so this is all about your DAX breakdown. So these are some of the easy peasy built-in functions. Of course, we will be showing you all these things. Now, before getting ahead with average and date diff, let's try to see what is sum, average, min, max, count, COUNTROWS, date diff, and date add. We'll go one by one. So everybody has already seen what is sum, right? So I will be creating a new measure, which is average salary. So here I will create average, and you can see average on what? Average on estimated salary. So I'll just click on tick. It's done. So in the same DAX, let's say I want to have another card. In that, I want to add the average salary. And this is my average salary. Of course, the averaging is done based on unique customer IDs, right? Total value divided by the total number of customers we have. If you want to see the total number of customers, we can probably show you customer ID. It is 10,000 customer ID. So of course, this number divided by this number is your average salary, right? Now we will be creating some other functions, which is min and max. So let's try to create min and max. Very simple. New measure, minimum salary equals to min, and then it's asking you which column, and you can just pass estimated salary. So I will use another card, and here I will be using the min salary. So the mean salary is, the numbers are not quite visible. I'll go to data label, formatting data label, and then change it to none. So this is my minimum salary. Oh my God, somebody's salary is $11.58. That's horrible. Anyways, and let's say I'll just have it like this so that it looks good. Border, shadow, everything is done. And then we'll have the maximum salary. So maximum salary is, I will just copy paste this code and create a new measure. And here I will have max salary. Instead of min, I will use max. Okay. So these are some basic things, and they are very simple and very easy to do. Max salary, and this is how the max salary looks like. So these are all your basic DAX functions. Sum, average, min, max, count. Now let's try to see the count. Now count is very similar to this one, right? Here also we are doing count. Of course, I mean, you can also create a measure. Let's say I want to create count of records is equals to count. Counts the number in a column. It shows you that count keyword, count DAX basically counts the numbers in a column. So let's say I want to use which column? I'm using the customer ID because that's my primary key, right? And done. I will create another DAX very similar to this one. Here, not using my customer ID. Instead of that, I will be using the count of records. It's 10K. Same as this one, right? If you just want to change the formatting and see if the number matches, I'll do the same thing for this one. The number is matching, right? So it's up to you whether you want to create a new measure or not, because some things are actually possible on the go itself. So yeah, this is how it works. And the next one is count rows. Count rows is also a similar function like count. Let's say you want to do a count rows. Let's say I'll create a new measure. Count rows equals to count rows counts the number of rows in a table. And here we want to provide the table name. I will just provide churn modeling. Okay. So trust me, count rows and count are similar. I'll just cancel this and I will use count rows. It's same. Both are same. Okay. And then comes some of the date function, which is date diff and date add. Okay. So what is date diff and what is date add? So of course, in this example of Power BI, I don't have any date parameters. So what I will be doing is I will be using another data set. Okay. So let's say I have another data set, which is air passengers. And if you want to see the data, this is how the data looks like. I'll quickly create a table and I will add month and passengers. Of course, many people knows about this data set. This is a very classic data set, which we use in any machine learning examples. Air passengers data. So I have month, year, day, and all those things. Let's say you don't want day and quarter. So this is how your data looks like. Now, in this, let's try to create some date diff functions. Now, what is date diff? Now, of course, I think I have date diff and all these things covered in the next classes, but it's okay. So date diff basically tells you the difference in the number of days or number of years or number of months. So let's say I want to create. Now, before creating something, just try to imagine what is date diff. Date diff means for a particular date, probably it should give me some difference in days or something, right? Difference in date, probably. So should it be a calculated column or a measure? That's the first thing which you need to ask to yourself, right? Now I think that it should be a calculated column, because date diff will basically, if you have two dates, it will tell you the differences, right? Differences in days, months, years, or weeks. So here I'll be creating a new column. Oh, my bad, I shouldn't create it in this one. I'll create here a new column which is year diff. I'll have it as year diff, and then I'll do date diff. See, even if you don't know any date diff functions or anything, if you just type date, you can see everything is visible. All the recommendations are visible. That's how Power BI is. It's very easy to understand. Now, once I clicked on date diff, it shows me. It returns the number of units specified in intervals between the input two dates. What are my two dates? My first date is month, right? I mean, the name of the column itself is month. So don't think that it's month, right? So air passengers month and date 2. That means it's asking, you want to find the difference of your month date, like from the original date from the data set, and what. So let's say I want to use system date. So how to call system date in Power BI? Just call today function. Today is basically a date. And then once you click on comma, it's already showing you the list of recommendations. Do you want day, hour, minute, month, quarter, blah, blah, blah. So let's say we are doing it on year. I will use year, close the bracket and click on tick. That means my calculated column is created. I will expand it and just drag and drop my new created column. Oh, I'll just click on it. My bad. Yeah, that means my year difference is shown like this. 1949 till 2021. It's probably 72 years, right? Similarly, if you want to do a difference in month, just change it to month difference, quarter difference, day difference. All these things are possible. So this is how your date difference function works. Now your next function is date add. Let's see what is date add. I don't know. I think it is adding some days. So should be a calculated column. Let's say I'll create a calculated column. New date equals to date add. Here it's also giving me which date, number of intervals, and interval. So let's try to see. I don't know, maybe I'm very new to this kind of things. I don't know. Let's try to explore. So what I will give is, I will give the date column. On click on comma, okay, date column dot, let's say it's asking for year, comma, number of intervals. Let's say I will have 10, and then let's say I will have year, close bracket, tick, and then I will, okay, is not a type of date. This is not supported. Okay. Okay, let's click on this. And now my date, new date is created. I will just add this, and this is how it looks like, my new created date. Of course, I will not show the day, quarter, and all those things. I want to just show the, okay, let's show the month and year as well. So this is my newly created column, which is my existing date plus 10 years. My existing date is 1949 January. My new year is 1959 January. Now this is how it looks like, 1949, 1959. So that means I have just added the number of days. If you want to remove it, let's say 1949, you want to show 10 years back. you still have to use date add. There is no date subtract function. Okay, you just have to change the values to negative. If you click on tick, and this is how your new dates will look like. So that means the dates are not available, right? For those dates, the dates are not available. So for dates which are available, you can see here. For 1959, it is 1949. For 1959, it's 1949, something like that. Okay, so this is all about your date diff and date add functions. And moving on to calculated table. Now, calculated table is also very important, and we'll see what is a calculated table. That means I'm going to create a new table which is on calendar date, and I'm going to pass a range of dates. So it creates a date table with a date per day between the specified range. So let's try to create a new calculated table. I hope everybody is clear about all these basic DAX functions. Now there are three tabs here. One is report tab, one is your data tab, and one is your model tab. Of course, we will be teaching you about the model tab in couple of next classes. Let's go to the data tab. So here, let's say I want to create a new table based on this calculated table. So new table. So here I already have the command ready, so that we don't want to write and make it a huge video. So I have a new table which is calendar of, you can see the calendar of range. That means I'm going to pass a range. So here I have passed two dates, 1949 January 1st till 1950 end. That means just 2 years. That's it. I'm going to create a new table having 2 years. If I click on OK, this is how my date column looks like. Okay. If you want to select, just keep it date, no problem. And from here, let's say we want to create some new columns. Let's say year, month, and month number. So let's say I'll calculate a new column. So what is my new column? Year equals to new table date dot year. Simply my year is created. How to create my month? Simple, month equals to new table of date dot month. I'll just copy paste it because we are going to reuse it again to create a new column which is month number. Month number is basically month number. Done. So this is my new table that has been created. And let's say I want to somehow merge this table, or else let's say we want to show the data for only these two months. So what I'm going to do is I'm going to merge this column. So this is one of my tables, and we have my air passengers data. So I'm going to create a relationship. Okay, I'm going to go to model. So this is my churn modeling, which we are not using in this particular example. We have air passengers and we have this new table. So this month and this date, I want to merge the relationship. So just drag and drop it to the date column. That means a relationship is created. Okay, now I'll go to my reports. For the time being, I'm just deleting this table and I will have this table here. And here I'm just going to remove all these things. So I will just have the basic data, all the data. Okay, this is my original data. Now what I want to do is I want to add the new tables month, and let's say I will just deselect the original month. That means I want the, let's say we'll create a new table for this. Let's say we'll create a new table. Just don't want to have, okay, we have this table. I will have another table. Okay, so these are the two tables that I have. Now in this table, let's say I want the summarized data for only those 2 years which has been created, right? Let's say only for 1949 and 1950 I want the data. Now, of course, there are multiple ways to do that. So what I'm going to do is, okay, let's try to have the month and then we'll have the number of passengers. Simple. So this is how the data looks like. Now, if you ask me, April, what is 264? Is it all the Aprils in the original data? Let's say the original data is having from 19 how much? From 1949 till all these years. So is this April data combining the data from all these particular if your question is this April data the combination of all the Aprils? No. If you click on April, you can see it is only the combination of 1949 and 1950, because that is how my new table has been created, right? I just have 1949 and 1950s data. Of course, you can also have a slicer to have the dates, and you can do that. As I told, multiple ways are there in Power BI, and this is how your calendar functions looks like, right? If you go to my calendar function, this is how my calendar function looks like. I have created a calendar table which is for 1949 till 1950, and based on that I have created this. Now if you ask me how to sort these numbers based on the month, because it's just sorted based on alphabetically, right? So we have to go to the table, click on month, click on month, click on sort by columns and month number. Click on month number, sort by columns and month number. If I go back, now my values are updated. This is how my new table looks like. So this is a summarized data, you can say. Okay. So this is all about the basic DAX functions. Now there are two different type of contexts. One is row context and one is filter context. Let's try to see what each one of them means. We'll talk about row context first. Honestly speaking, if you have already gone through the DAX videos, that means you might have already done some sort of calculated columns which is impacted on row level, right? That's basically your row context. We already know how it works. We have been using it for all our calculated columns so far. Let's revisit our first DAX. So when we were creating our first DAX, I told you, right? Let's say we have a column called as tenure. We don't know if it is in months or years. So first thing as a data analyst you should do is to clarify whether it is in months or years. I'm just assuming it to be in years, to be in months. I don't know. Let's just assume it is in months. Okay. So that was the reason I created a new calculated column, which is churn modeling of tenure divided by 12. And I have just used a round function so that I want to keep the decimal places up to 2 decimals. That's it. So we have created a tenure in years, and you can see the values are different for different rows. So this is basically a row context. We expect a value per row in a table. This runs at import and gets stored. Might increase the file size. It's not might, it will increase the file size. The more calculated columns and measures you create, the more file size will be, and the more memory consumption will be from the Power BI side. Okay, because that was the main reason why we don't really use a lot of DAX functions. We use DAX only when it is required, or else we just try to use the inbuilt functions to get the output. Okay, now what is filter context? Easy to show with measures. Now filtering, what is filtering when it comes to SQL? Let's say I want to have the total salary of all the candidates. That means total salary from table name. It will give me the total salary of all the candidates. Just imagine if somebody asks you, can you give me the total salary only for males? That means you are restricting the total salary only to males. Then what we need to do is we need to add a where clause. So what I will do in SQL is I will add a where clause where gender equals to male. Simple. So let's say you want to have total salary for people staying in Mumbai. Salary from table name where location is equals to Mumbai. Let's say total salary of people For people staying in Mumbai and Kolkata, you use your in keyword in Mumbai, in Kolkata. Something like this. That's what we do, right? And these are all your filters. These are all your filters. So we also have a filter keyword in Power BI, and we will see how to use the filter context. So to use filter context, we usually use calculate keyword. Calculate is breaking out of the filter context. How it is used? Variable name equals to calculate of something, comma, where category name equal to beverages. Let's try to go to the Power BI desktop and create our first filter context variable. Okay. So we already have, let me just delete this tag, delete this card. We already have the total salary, which looks like this, right? Sum of my estimated salary. Let's say I want to have the total salary for male and female. So what we need to do is I will create a new measure. What will be the new measure? Total salary male. So here I need to use my calculate keyword. Calculate. Once I use the calculate, you can see it expects an expression and a filter. Evaluates an expression in a context modified by filters. So what is your expression? Going back to the notepad, this is your expression and this is your filter. Okay, so see how I'm using the expression. I will be using sum of estimated salary, bracket close. So this entire thing I am using here. Okay. And after that, I'll be using the filter. What is the filter? I'm going to use gender equals to male. So I'll use gender equals to male. I'll close the bracket and I will click on tick one. That means my measure is created. I will just copy it and recreate the measure for female. Take it. Now by both the measures are created, total salary for male, total salary for female. Okay, we'll create a card. Let's try to create a card and I will add total salary of male, copy paste it, and I will add total salary of female. Simple. Now this is how it looks like, right? Of course, if you want to show these numbers, you can also show these numbers without creating a measure. Let me just do that for you. Let me just minimize this for a little bit, for a while. Here, let me just add a background and a border so that it looks good. We have created a new measure or a filter context, and this looks good. I'm just copy pasting these things. Now here, I will be removing the measures that we have created and we will be trying to use it without creating a measure. That means I want the total salary for male and total salary for female. So in this box for male, what I will do is I will put the estimated salary, which is my raw column. Here I'm doing a sum operation, everything is good. And going back to the SQL query, what we will do is we will add a filter, right? So my filter is going to be gender. I am dragging my gender into filter and here I will be checking male. Simple and done. This is done. Same thing for female. I will click on my visualization. I will drag and drop my estimated salary. I will recheck if it is sum, done. And then I will add my gender into my filters and then select the female. You can see how simple it is. So some people think that DAX is required. Of course, DAX is required. There are hell lot of situations where DAX will be required, but there will be a lot of situations where DAX is not required at all. So if it is not required, if there are other ways to do it, 100% pick that way. Because once you start creating DAX and start creating measures and calculated columns, that means you are increasing the column sizes, right? You are adding one new column, you are adding one new measures. That's going to be impacted as well. because your memory will be impacted, your file size will be impacted, and all those things. Anyways, this is how the filter context looks like. I hope everybody understands about the calculate method. There is another way how to filter. You can also use a filter something equals to something. We'll try to do that as well. So I will just do it for the male population. I will just close it, close everything, close the filter, and then I will go to my formula, copy paste it, create a new measure. Now total salary male using filter. Okay, so here instead of this one, what I will do is I will add a filter. So I will add filter. Again, in filter, it is asking, what do you want? It returns a table that has already been filtered. So in the filter, what you are doing is you are by default filtering it. So let me just write down and I will explain the difference between this method and that method. So filter of table. So I will pass my table, which is churn modeling, and then I will ask the filter expression, which is gender equals to male. If I close this, everything should be okay. Double close and done. Now in this card, I will be using the new variable. You can see the numbers are matching. All the three numbers are matching. Now, looking at the formula, let me just copy paste this code to my notepad and copy paste this code to notepad so that we will see what is the difference between each one of them. This, and the second type is this. Okay. These are the two methods which we learned how to filter. This is using filter and this is not using the filter keyword. So this is basically directly like this. Okay. You can assume this to be this, but the first step is nothing but it's a two-step. What it does is it first filters the table based on only male, and then on top of filter, it calculates the sum of the salary from. It's basically like this. So in a way, both are same. Both will definitely give you the same amount of values, but these are just two different ways of filtering it out. If you want to do it using filter, you can do it. Without doing filters also, it's possible. Okay, so these are both the ways to deal with it. Now variables, var my var equals to 1. This is my data type, this is my variable name, and this is my variable value. I think everybody has already known about all these things, right? Our next step is going to be understanding more about if else blocks and nested if blocks. Now, I assume that you might have already gone through various Python programming languages. So you might already be knowing about if else blocks, right? So for example, if you want to write whether a column is, whether a value is even or not, right? If that value, let's say, is equals to 2, that says that we can print a is even, something like that. So if else is nothing but print odd. Okay, something like that. So if else blocks are nothing but if this, then do this. If not, then do something else, right? So that is the reason. What we can do is we can create a first method. We can create a new column. Let's say I want to create a age bin. Okay, so we can create a new column and this will be age bins. Now, before creating it, I hope everybody knows that there is a column called as age, right? Let's say we will create a new column which is age bins using if else blocks. So what I need to do is, if logical test, if my age is greater than equals to 60, then what I will do is above 60, else below 60. Simple. It's a very simple if block. That means if this, then this, else this. That means anybody's age who is more than 60, then I'm going to create a new column which will say above 60. Other than that, all the values will be below 60. Simple. So let me just add that newly created column, which is age bins, and this is how it is. All the values are below 60, and if you just filter out the age like this, it is above 60. Oh, age is being there are some above 60 as well, right? And let's say you want to take it to the next level. That means you want different bins. For example, you want to create bins of 0 to 20 age, 21 to 40, 41 to 60, and 60 plus, something like that. How can we do it? Simply, I will just copy paste this code. That means if this, do this, else if greater than 40, then mark it as 40 to 60, else if greater than 20, mark it as 20 to 40, else below 20, something like that. So you can see, if this, then do this, else if this, then do this, else if this, then do this, or else do this. Now I'll just change it, and you can see the age bins are updated now. If you want to just create a new bar chart and want to see how the distribution looks like based on age bins, let's say I will have my age bins in my axis, and let's say I want to have the total number of customer ID. I will have it in count. Yeah, this is how it looks like. You can see this is how the data looks like. 20 to 40, 40 to 60, above 60, and below 20. Of course, as I already told you, there are multiple ways to do this, right? Without, this is how you have created using if else blocks. You can also make your life simple and do it using the Power Query editor. Go to the Power Query editor, add a column, create a conditional column, let's say new age bin. And this is how you can also create if age is greater than 60, above 60, else if age is greater than 40, then 40 to 60, else if age is greater than equals to 20, then 20 to 40, else under 20, something like that. And you create it, go to home page, close and apply, and then you can just simply let it finish. It's preparing. I mean, it's loading. Just 1 second. I will simply expand this one. Let me just drag it here. I will expand my table. So we already have age bins. I'm going to add the new age bins. Where is that? New age bins. You can see my new age bins is also having the exact values like we have used using the if else blocks. Now this is all about your advanced DAX functions. Now, before getting into time intelligence functions, I hope that everybody knows about calculated columns and measures, right? Calculated columns are something which is done on row basis. For example, if you want to combine first name and last name and you want to create a final name, or else if you have ages, probably you want to create some bins, or else maybe let's say you have tenure in months, you want to convert it back to years, or else vice versa. So anything that has an impact on a row level is basically a calculated column. And measures are something which is done on the table data itself. For example, if you're dealing with a lot of records, and let's say you want to find the total count, or else you want to find the total sum of the sales, or else the total balance. So all these kind of things on a tabular format, on a table, and on a table as a whole, we have to summarize everything. So that's basically a measure, right? Now, what is time intelligence functions? Time intelligence functions enable you to manipulate data using time periods such as years, quarters, months, days, and creating calculations over time, those time periods. The most common time periods that we encounter in business scenarios are year to date, month to date, quarter to date, last year, full year, rolling 12 months, etc. etc. There are many other time intelligence functions in DAX. Now, in this session, we shall be learning about few of them, and of course, other than that, what is being taught in this class, you can just self-practice it. Because as I already told you, Power BI is super simple to understand and super simple to implement, right? So the first function which we are going to use is going to be total YTD. Now, just imagine you have sales data or else sales, and you have month. Let me just increase the format. And let's say you have month. Let's say $120 for Jan 2019, 180 for Feb 2019, 130 for March 2019, 200 for April 2019, and so on. And you have data for like 10 years, 20 years, whatever you have, right? YTD basically means, let's say I am selecting March 2019. That means year to date. That means the entire sum till the date you are providing. Of course, if you provide Feb 2018, that means Jan and Feb's data. If we take an example that will make us more, we will get more understanding on these concepts. Now, the formula wise, this is how it looks like. The left side is my variables, which is YTD total sales. It could be anything, equals to total YTD. And then I'm passing that on what? On this measure, that on top of sum of something, then dates. So let's go back to the Power BI desktop to understand more about it. I have done a small visualization, a small report kind of thing, and I have multiple things to cover. So first topic is going to be YTD. Now before YTD, I will show you how the data looks like. Of course, churn modeling is something which we already have. I think everybody knows about it. We have air passengers. Now, churn modeling does not have a date column, right? So I cannot show you how time intelligence functions work. So we have air passengers. Now this is my month and this is my total passengers. Simple. So here I'll just close it. What I have created is I have created a new measure, which is total YTD passengers. Now, if you look at it, it tells me that, hey, can you create the total YTD for the number of passengers? Of course, to enable the total YTD, you need a slicer. That means you want to select the dates, right? That's the reason I already have a month slicer. This table is basically being used by air passengers too, because that's another query. Why? If we use the same query, probably if we filter it out, my table will also be filtered, right? That is the reason I have shown a table using another query. Okay, same air passengers, just copy pasted the queries. Now going back to the formula, total YTD. So here we have created total YTD, sum of air passengers on my date. If you simply don't remember these formulas, it's completely okay, because once you start writing the formulas in Power BI, whether it is total YTD, QTD, let's say YTD, it already tells you your first should be an expression. That means it should be a measure, and then dates, and then filters. So that's the reason we already have all these things. Okay, now if I just, there is some, okay, small mistake and done. So this is my total YTD passengers. Now look at this particular table. What I will do is I will first select January. So for January, my YTD is going to be January's data only, right? That means year to date. So if I click on January, you can see my value seen is 112. If I click on Feb, that means it's going to aggregate the values 112 plus 118, that has to be 230, right? If I do this, then 230. Now, if you ask me what is the difference between yearly data and YTD, now if you are selecting yearly data, irrespective of the month, if the year is 1949, then the yearly sum will be the entire 1949 data, right? But YTD is something like year to date. That means till the date we are selecting, what is the annual sales or what is the annual number of passengers, right? Similarly, if I just do it for December, that means it's going to accumulate from 1949 January till 1949 December. Very simple. Again, the same concepts. If I do January 1950, it's going to show me just January 1950's data, 115. And similarly, if I do July 1950, it's going to accumulate from Jan 1950 till July 1950. As simple as that. That is a concept of YTD. And why I'm not showing you other methods like other functions, because it's all the similar way. If you want, you can just simply copy paste the codes and then create another measure to validate, let's say, total MTD passengers. Okay, because it's monthly data, so MTD, there is no concept of MTD. MTD means month to date. Let's say your data is in daily format, and if you are doing month to date, that means if you are selecting 15th of April, that means it's going to accumulate from 1st to 15th of April. But as we just have monthly data, so MTD doesn't really matter. But still, for your understanding, let me do this MTD and just do tick, and I will create another card for this. I will just add MTD. See, July 1950s MTD data is going to be July 1950s normal data. So it doesn't really matter. So it's going to show you the same data. So MTD and QTD will be impactful, because QTD is just the accumulation of 3 months, right? Now what is QTD? 1 year is divided into 4 quarters. And let's say you are selecting Feb 2019 or Feb any year. That means it's going to accumulate Jan plus Feb's data. Simple. You can do the same thing and just try it out. Let's say I did the same thing from MTD to QTD, and I will just change it to QTD. Done. And you can see for July, for Feb, it's basically accumulating the January and the February data. January and February is 241. Now, what will be Jan, Feb, March is first quarter, April, May, June is second quarter. Let's say I do May. So May, you can see for May, the YTD data is the accumulation of January, February, March, April, May. That means 642. But for QTD, it's going to be only April and May, because that's basically your second quarter, right? And this is how you can all create the total YTD, total QTD, and total MTD. So this was one of the major time intelligence function. Apart from that, we have another function called as previous month. Again, we also have previous year, previous day, next month, next day. So if you learn one of them, it's very easy for you to learn other things as well. Okay, so for previous month, you can see the formula is total sales something. That means I want the total sales for the previous month. Simple. Let's say my slicer has been selected for May, and I can see my this month's sales. I can also see my previous month's sales. As simple as that. So we are doing calculate. What are we calculating? The measure, that means sum of some column, and then there is a function called as previous month. Okay. Again, so here you can see on the screen, I have three things. Let's say I'm talking about May, right? Now in May, what is my current value? 125. You can see this is showing me the passengers this month, 125. What is my previous value? 135. This is showing me the previous value, which is 135. What is my next value? 149. This piece of card is showing me the next value. Let's see what each one of them is. Let's click on this one first, previous passengers, which is using past prev measure. If I click on my measure, this is how the measure looks like. I have calculate what? I'm calculating the total sum of the air passengers. Now we already know how this thing works, right? This is nothing but sum of all the air passengers, right? And then I'm using this. So this basically is acting as a filter, right? You can use this, or else you can also do filter month equal to, date add. So there are multiple ways to do this kind of things as well. I'll not make it complex. We are just focusing on the time intelligence problems. So that's the reason. Let's talk about previous month itself. So here, sum of this, comma, previous month. See, if you don't understand, you can simply type in previous month and it will show you what exactly it is. It returns a previous month. If you are providing dates, it's going to return you the previous month. That's it. If selection is May, your output will be April. Simple. And then this is how it is. And the difference between this and this is nothing, just a single keyword. If I click on this, I'm using pass next. If I click on pass next, I'm using next month. Very simple. Let's say you want to create another kind of card to show which month is selected month. So I'll create a card. Let's say I'll create a card. And here I will create another measure, which is previous month is equals to previous month on what? On my date column. My date column is month. The column's name itself is month. Don't get confused. Month, and then I click on this, done, and then I drag my previous month, and this is how it looks like. Okay, of course you can just have the, you can format it as well. It's up to you. Okay, and this is the previous month. And similarly, you can also add the current selection or else the next month as well. Let's say, let's create the next month. Next month is equals to next month on what? On month. Done. Click on the visualization, just drag the next month. Done. Simple. So it basically tells you that my current selection is May, my previous month is this, and my next month is this. Now this is how we can actually use the time intelligence functions. It's very useful for, let's say you are doing sales analysis or any kind of analysis where you are actually comparing your previous values and your current values, right? Then definitely it's going to be useful. And so yeah, I mean, that's it about the time intelligence functions. What is X and non-X? Which basically means there are many functions like sum, average, max, and all those things, and they have their X variants as well. For sum, we have SumX. For average, we have AverageX, and there are some other X functions as well. But in this session, we shall be learning about few of them. Now, what is the difference between sum and SumX? Sum, as we already know, that it's basically a measure, right? For example, if we want to find the total sum of sales or total sum of some column, whether it is on the entire table or whether it is having some filter clause, but any of the scenarios you use sum, right? Now, what is SumX? SumX is basically an iterator function. It works row by row. So it is again a measure, but it works row by row. And iteratively it calculates. So we'll talk about that from the practical point of view. Now SumX has awareness of rows in a table, hence can reference the intersection of each row with any columns in the table. So we'll get started with the sum and SumX example. For this particular exercise, I am using this supermarket sales dataset. You just have to search supermarket sales dataset Kaggle and you will get the link in the first link itself. Super sales dataset. and this is what the data set is. I'm using the same data set. So let's get started with it. We'll jump on to Power BI. You can see here, I already have a small dashboard or a report. This is my total revenue by date. Let me just show you the data. Now, this is how the data looks like. We have invoice ID, branch, city, customer type, gender, product line, unit price, quantity, and all those things. Now, just imagine you have the total number of products sold and the unit price of a product. That means each product costs $10 and you have 10 products. So what is the total sales for that product? 10 into 10, right? $10 into 10 products. So similarly, here we have a column called as total, which basically is unit price multiplied with quantity. We can just validate it for the first record, 74.69 multiplied with 7, which gives me something, plus the tax, which is 26.1415. That makes it the total column. Now, can we also have the total on the go without creating this column, without having this column? What is the advantage? The advantage is that instead of n number of columns, you will be using n-1 columns, which is a win-win scenario, right? Because the more columns you cut down, the more memory you can get for your activities. Of course, because more columns, more memory consumption, right? So how to achieve it using SumX? So let me take you to the main screen, which basically shows some graph, total revenue by date, and I have a simple table, which is like date and the total column. We already know how sum works. If I just have to show you, so total sum is equal to total sum of sales is equal to sum of what? Let's say sum of total, because we already have this column, right? Can we use any other columns? No, we cannot do that. We cannot do something cross something and then do a sum on it. So if I do this and then if I have a card on it, this is how the total sum of sales looks like. But our main activity was, can we get a similar column like total without using the total column, right? So here, what we will be doing is we will be creating a SumX measure, total SumX, which is SumX. You can see when I'm using the queries, when I'm calling the DAX functions, Power BI is automatically suggesting me that you need to pass a table and an expression. Okay, returns the sum of an expression evaluated for each row in a table, right? That means if you have unit price, quantity, and something else, and you are doing some mathematical operations on it, and you want to have a new column, of course, if you are not using SumX function, you can create your own conditional column like total, right? But here we don't want to use total, we want to get rid of it. So here I will pass my table name, which is my super sales, and then I will pass my expression. What is my expression? I already explained. What is total? Total is quantity multiplied with unit price plus tax. Simple. So I will be doing quantity multiplied with unit price plus tax. And then I'll close the bracket and then I'll tick. That means my measure is done. I'll click on the table and then I will just add this column. And you can see that it is exactly the same like total. Now, even if you delete this total column, you can still have this function. Now, what is the advantage of this one over the first technique, which is creating a separate column? The advantage is that when you use your X functions like SumX, the data is created in memory. So when you are calling the SumX function, it does it for each rows, right? So what happens is in backend, it creates the table in memory. And once you are using it in form of a table, then that means you are using the data from the memory directly. So you don't have to create a separate column out of it. That is the advantage of it, right? So you can simply go and just delete the column, as we have already validated it that I don't, you can see both are same, right? So I don't need my total column. You can simply go to your Power Query editor and then simply drop it off because we don't need it. And then close it. Done. Of course, this will be a failure because this column does not exist. So I'll just close it off. It's loading. So I hope everybody is clear that you can see everything is done. So, okay, the idea is that without having a new column, we are still able to calculate some functions using the SumX method, right? So I'll just remove this step because we can get this back again. Okay, now this is done. Let me just add it so that we have it in the table itself. Now our next function is, you can see this is how it is used, sum versus SumX. Next one is, we'll talk about average, average A, and average X. Now average we already know. Average means averaging out the data, right? So if you want the total sales, let's say here you have the total SumX. Let's say I'll be using this particular table. So I have product line, unit price, quantity, and tax, right? Let's say I want to use the total column here. So here you have the total column and you just want to change it to average, right? So this is your average. Average of total. I mean, we already know how average is calculated, right? Now, what is the difference between average and average A? So I'll take help of Excel to explain you what is the difference between average and average A, because using Power BI, it will be a little bit difficult to explain, but using this, we can easily explain. The concepts are same. So let's say I have a product and then I have sales. So let's say product is, let's say I'm talking about some products. Let's say soap, pencil, pen, eraser, something like this. And then product X1 and product X2. We have 6 products here. And then let's say okay, we'll take help of sheets.google.com. So let's say I'm using a blank sheet. Let's say I have product and I have sales. So let's take some random values, A, B, C, D, E, F. These are my 6 products. Let's say 10, 15, 20, 25, something, and 10, right? Now what is average? Average and average A. Okay, so average is nothing but, if I do average of this, it basically calculates 16, right? Now, what is average A? Let's say I have 5 records. What will be the average? 10 plus 15 plus 20 plus 25 plus 10 divided by 5. Simple, it's 16, right? Average A will also return me 16. Average A of this will return me 16, same. So what is the difference? The difference is that sometimes in your numerical columns, there could be some null value, there could be some string values or some sort of text values, right? For example, you have a text like XYZ. Now, if I hit enter, that means this one is considered as 0 as per average A, but average still does not take care of it. So you can see, once I am using a text variable here, average is still considering only 5 elements. So your average is still 16, but average A treats it as So this is what average A trades like this. Now the total sum is 680, and then it is 80 divided by 6, which is 13.33. So that is the difference between your average and average A. Simple, right? Now moving on to average X. What is average X? The idea remains the same. The idea is that can we have this column without creating the column? Like without creating a physical column, can we create the data? Can we use the data, maybe using some memory usage, right? So here I'll be doing the same thing. I'm just calling my new measure where I will be having average X, which is average X, let total average X. Okay, average X of what? If you type in, you are seeing that we have to pass a table and an expression, right? Simple, it's going to be same. So the table is super sales and the expression is unit price multiplied with quantity plus your tax. Do this and then close the bracket, click on tick, and then in this table I will be adding that, and now you can see both the data are same. So whether you are doing an average of your that column or you are creating it in memory, so the idea remains the same. So why don't we use the X function? So these are the advantages of X function. We can simply use X functions without creating an extra column, which saves your memory, which saves your CPU utilization, and there are a lot of advantages of it. So you can explore these kind of X and non-X function to understand more about it. But generically speaking, X functions basically saves the space. You can create the table in a memory and then you can use it on the go. So these are all about your basics of your X versus non-X function. In the next videos, we shall be learning about some next topics. Thank you.